In this lesson, we're going to be going over Sleuth Kit. Sleuth Kit is actually a set of programs that has been designed for being able to look at disk images that have been acquired. So there's a set of programs that allow you to look more closely at these images that we've received. And by images, I'm talking about, for example, a raw image that you've acquired using DD or DCFL DD. So Sleuth Kit is designed for Linux systems, which is where I'm using it right now. You can actually get Sleuth Kit as part of some of the other forensics-oriented live CDs or Linux distributions, and you can find Sleuth Kit there, although Sleuth Kit is also available just as a package for Ubuntu. Now, there is a graphical user interface, sort of, that comes along with it called Autopsy, or you can download Autopsy as well as Sleuth Kit. Autopsy is actually a web interface as opposed to more of a traditional graphical user interface along the lines of ProDiscover or Encase. So if you launched Autopsy, you'd then have to launch a browser and connect to the Autopsy server that would allow you to import these disk images and be able to perform some analysis there. What I'm going to do here, though, is just use the programs that come with Sleuth Kit right on the command line, and we'll be able to see exactly what's going on and get the results directly. So the first thing is I've got a disk image called ntfspract.dd. And so I want to take a look at that disk image. And so the first thing I want to do is use a program called MMLS. I'm going to give it the disk image name. Now, what I'm getting back is the partition table. I've got the partition table here, and one thing that's important to note is the start point for really the partition that we're going to be most interested in. If you look on the right-hand side, it says description. We don't care so much about the unallocated partitions there or the unallocated slots. What we care about is the one that says NTFS. If you go over to the left of there, you'll see start is 59. Now, in order to use the rest of the tools that we're going to be looking at, we have to keep that start block in mind, because we're going to have to tell these programs to ignore the first 58 of these allocation units and start at the 59th. So what I want to do now is get a file listing, and I'm going to do that using FLS, and I'm going to say the image format is raw, and the file type is NTFS, and then I'm going to do my offset of 59. So in other words, start counting or start paying attention at an offset of 59. Just ignore the first part of it, because that's actually the partition table and the boot block and all of the other things that we're really not interested in. What we're really interested in is the partition where all of the data is. So I have an offset of 59, and then I'm going to give it the file name here. And what you can see is I've got the files and directories that are on that particular disk image. Now, not only do I have the normal ones like My Documents, Favorites, and Desktop, but I've also got, you'll see, the $MFT and the $log file. So that has to do with the $MFT is actually the master file table, and you'll see the master file table mirror there as well. And of course, the log file, which is the journal that's kept for the purposes of ensuring that the file system is clean and intact and complete. So what I can do now is use a program called fsstat, and I'm going to get statistics from the file system. So I'm going to say a raw image. The file type is NTFS again, and then of course my offset is 59. And I give it the image name, and now I've got information about the file system. You can see that the file system type is NTFS. I've got a volume serial number. I've got a volume name, just says new volume, and it says the version is Windows XP. So this apparently came from a Windows XP system. Now I've got content information, so my sector size is 512 bytes, and my cluster size is 4096 bytes. You can see all of the other just pieces of information regarding this particular file system. FSStat will give you information about the file system from the image that you provide. So it reads the image and gathers these statistics and presents them to you in a way that you can easily see. Now I'm going to use another program called Sorter, and what Sorter is going to do is it's going to give me all of the different kinds of files that are on this particular disk image. And my offset is 59, and I'm going to say we're going to use C, and the directory is savedir. So that's the directory I'm going to store all of the files. And now I'm going to give it the image name. So Sorter is going and running through all of the files that it finds on this particular disk image. Now, if I go into savedir, now I've got all of the different file types. So what have we got in images? So you can see that there are several images that were stored on that image, and it gives you the inode that's associated with the image, so we know where exactly on the image or on the drive that these particular files are stored. And we've got several others, so exec.txt would be executables. So let's see what we've got there. We've got, looks like a couple of executables. We've got DTR set up and root.exe. So those are executables that are there. Now, there are some unknown as well. So it looks like there's a shortcut. It says internetaccess.lnk. That would be a shortcut or a link. And we've got a WMV file, which is a movie. So there's some unknown files that are there. So I can also look at some of the inodes here. Minus F is NTFS, minus I is raw, minus O is 59. That's my offset again. And I want to say NTFS. Actually, I need to go up a level before I do that. Minus F NTFS, minus I raw, minus O 59. And let's look at inode 131. And I've got these out of order, so let's put the inode number at the end, 131. So for inode 131, I've got the file name ultimatejourneydk.wmv, which is what I expected to see because you can see from the sorter application, it gave me ultimatejourneydk.wmv, and it told me what the inode was. So that was the inode that I fed to the iStat program, and now it's given me statistics regarding that inode value. So I've got my MFT entry header values, and I've got the attribute values, and then I've got the attributes, and you can see under the file name attribute values, I've got the name is ultimatejourneydk.wmv. And I can see that my parent MFT entry is 72, so I could go digging backwards through that and figure out where it actually was from the inode entry. You can see here there's a lot of capability from the standpoint of looking deeply into a disk image using these commands that come with Sleuth Kit.